Good morning. It's my pleasure to introduce James Foley, winner of the 2007 CHI Lifetime Achievement Award this morning. Jim was instrumental in contributing to HCI's foundations, especially as it concerns shares with computer graphics and in establishing HCI as an educational discipline. James D. Foley is a professor in the School of Interactive Computing in the College of Computing and a professor in the School of Electrical Engineering and Computer Engineering at the Georgia Institute of Technology. He's the founding director of Graphics Visualization and Usability Center at Georgia Tech. Other past positions include the CEO of Yamakra, Georgia's Economic Development Initiative in broadband, and the director of Mitsubishi Electric Research Laboratory and chairman and CEO of Mitsubishi Electric, directing 4 labs in North America. He's a fellow of the ACM, AAAS, and IEEE, and a recipient of the ACM SIG Stephen Coons Award for Outstanding Creative Contributions to Computer Graphics. Professor Foley was one of those computer graphics pioneers who came over to help establish HCI as a discipline. He's the first author of the leading text in computer graphics, a text, if you've seen it, that weighs about 700 pounds, part of which deals with core technical HCI issues such as input devices, interaction techniques, and dialogue design. From this base of credibility, he established the Graphics Visualization and Usability Center at Georgia Tech. This institution became a major center for HCI research, the training of students and future faculty, and the codification of courses and content in the field. It gave credibility to the entire field. It's difficult to think of anyone who's actually had a larger role in the institutionalization of HCI as a discipline than Professor Foley. Foley's technical work has been characterized by its breadth across HCI. He's contributed over 80 publications spanning computer graphics, input devices, visualization, user interface evaluation, perceptual issues, and user interfaces. I give you James D. Foley.
Thank you, Steve. Thank you. Good. Thank you. Thank you very much, and good morning. Many forces have converged to make it possible for me to be standing here chatting with you this morning. Most important, my family. I recall a time at the University of Michigan in graduate school when I was getting a bit discouraged about being in graduate school. You know, there were comps and quals and all that stuff. My wife, Mary Lou, who's sitting right here, put up your hand, kept encouraging me and helping me, and thank you, I love you. I have a great grandson, a wonderful grandson, JD, whom you see here in this picture. JD and I love to play trains together. Early on at North Carolina, Fred Brooks and Vic Wallace were my earliest colleagues nurturing my interest in user interfaces, and I thank them sincerely for the encouragement and the help. Vic and I worked together on a number of research projects and wrote several papers together. Later, I got to know very well Andy Van Dam, with whom I did a lot of writing. When I first got to Washington, Ben Snyderman welcomed me into the Potomac chapter of the Software Psychology Society. No dues, no members, no officers, but we had a great time. John Seibert at GW worked with me on many projects, and we continue to be good friends, as with all of my former colleagues. At Georgia Tech, Peter Freeman and Pat Creasine were strong supporters of founding the GVU Center and of founding the College of Computing at Georgia Tech. And then, of course, at the GVU Center, I had the great joy of working with many people. Here I have the approximate time of arrival, starting with Al Botter in the upper corner. Oops, sorry, that wasn't supposed to happen. Starting with Al Botter and John Stasko and Beth and Keith and others. This is about when I arrived. The point is that Georgia Tech was already a rich environment for developing what has become the GVU Center and the School of Interactive Computing. So thank you to all of my colleagues who have joined with me in this passion of developing the interface between computers and people. I have another passion, and that's trains. I told you that my grandson JD and I like to play trains. This is my backyard. This is a moment I've been waiting for a long time to be able to show these pictures. Here's some close-ups of the train. And here's the action picture that I've been promising some people. In the background there. This is now on the inner loop of the train. The train has two loops, a long loop and a short loop. This is the shorter loop. We're coming around the bend, going a little bit too fast, and that was a real crash. I am pleased to announce that Gary Olson and I are today forming SIG Trains. A show of hands for the railroad fanatics in the audience. Hey, okay, we're going to have a meeting right afterwards. So seriously, back in what we might call the good old days, HCI was not HCI. It had many names. It was man-machine dialogue, man-computer dialogues. You know, the man had to go. That was a carryover from the bad old days. User-computer interfaces, user-computer dialogues. I started teaching a course on user interface design in 1978 at GW, and here's an approximation of the outline. I actually pulled this off of an old file on my Mac. You notice in italics, there are these Software Psychology Society, oh, go away. There are these Software Psychology Society meetings. We met at GW, and it was a great way to have my students get familiar with user interfaces and for us to build a Washington, or to expand the Washington-based community with Ben and Gary and lots of other folks. There were a couple of early books that were kind of influential. This was before textbooks came along. Jerry Weinberg wrote The Psychology of Computer Programming in 1971. This is one of the earlier books to deal with the relationship between computers and people. And I've listed here a couple of the chapter or section headings. You get some sense of things that were talked about 36 years ago. James Martin wrote a very nice book for the time, except for the title, a little to one-sided, Design of Man-Computer Dialogues, a slightly Dr. Strangelovian cover also, but good topics. So that was 1973. In the old days, there were just a few conferences. Best I've been able to determine, the first conference that published proceedings was what was originally called the Canadian Man-Computer Communications Conference and later became Graphics Interface, a series that continues to this day. Human Factors and Ergonomics Society, which then was just the Human Factors Society, had been holding annual meetings even before 1972, but their first published proceedings was in 72. And if you go online and go to their index, you'll find a number of nice papers about user-computer interfaces back in that time. And in 1974, the SIGGRAPH Computer Graphics Interactive Techniques Conference started. I'm told that the conference that Ben and Al Botter organized in Atlanta, whose proceedings were published as Directions in Human-Computer Interaction, I'm told this is believed to be the first use of the human-computer interaction term. This conference had papers by some names you recognize, also some names you wouldn't recognize if you were to look at some other names. And then Kai arrived in '82 with, at that point, the wrong name because as the precise historians would tell you, Kai as the name didn't start until '83, and this conference was not actually organized by SIGCHI. But in any case, it arrived. And HCI Education was there. I'm pleased that I was able to put together a panel session. Al was part of it, Tom and Stu were part of it, Ben was part of it. So folks have been thinking about HCI education for a long time. Then dating from, let's say, the early '80s, things took off. Our field expands dramatically. This is a list of, without doing complete historical research, this is a list of conferences in our field that started in the 1980s. So we have maybe 9 or 10 conferences here. And then we get to the '90s and the list gets even longer. And we get to the 2000s, and since the decade's not over yet, the list isn't quite as long as it will be, and there are yay many more conferences that have been starting in the last couple of years than are listed here. We're just taking off. The field is exploding. So it asks the question of us as educators, where are we going? As we see computers becoming more and more pervasive in the world, we need to focus, I think, on making our educational processes much more pervasive than they are now. We need to be pushing our curricular ideas into a lot of different disciplines, into a lot of different domains. So at Georgia Tech, we've started using the term human-centered computing for our newest degree program, as opposed to human-computer interaction. Folks have asked me, why a new name? Well, we felt it's not just about a human and a computer anymore, it's much more than that, and it's not just about interaction anymore. You know, HCC and HCI, use whatever name you like, really is at the intersection between human needs and activities on the one hand, computational capabilities on the other hand. So it brings together the human-centric and the computing-centric disciplines. So some of the human concerns that we bring to the table in HCC from using labels of academic disciplines are suggested here, and I would not suggest that this is a complete list, since computing is so all-encompassing. And there's a long list of the traditional computer science concerns. And when we bring these together, over the last number of years, we've evolved a large number of human-centered computing disciplines or sub-disciplines, ranging from HCI per se through a large set of issues and topics and areas. Notice that I've included in here things like usable security, usable networking, software engineering, programming language. I'm encouraged to know that things like empirical study of programmers, looking at the program development process, is coming back into vogue within our community. It was very popular some time ago, kind of died away as we worried so much about the end user, we forgot to worry about folks who are developing tools for the end users. And of course, there's the aspect of end user programming as well. So I think of HCC as being so broad that we need to be drawing in many different disciplines, many different people, and imbuing many of our academic disciplines, our traditional academic disciplines, with aspects of HCC. So how to do that? There are a lot of great models in the world. I'm going to talk briefly about 4 models that have been evolving at Georgia Tech. I'm not suggesting that this is the only way to go. I'm not suggesting that this is the best way to go. I'm suggesting that it's a way to go in hopes of encouraging further discussion and dialogue and development and understanding amongst the entire community of different approaches and their values. At the undergraduate level, we've started a program called Threads within computer science. You take any 2 threads and you have a bachelor degree in computer science. There are 8 threads total. 3 of those 8 threads have very much to do with people, and those are the threads that are here on the first page. And they all, clearly, these are people. The other threads, well, the first one, computing and media, is actually things like computer graphics and games, so it's very close. It's, if you will, part of enabling technology, and certainly games are about people. The other threads are your more traditional computer science. Threads has just rolled out, but the people thread has been very, very popular. What students study in the people thread, they have to take this set of 5 core courses in psychology and computer science, then taking 1 out of 3 psych courses, 2 out of 3 CS courses, and then 12 electives out of a long list of both CS and psych electives. This is not your traditional computer science undergraduate degree program, which is a good thing because, as I'll discuss later, we have problems with our traditional computer science degree programs. A new bachelor's degree called Computational Media, which is done jointly with our School of Literature, Communication, and Culture, Media Studies, in which students take 33 credits in computer science, 33 credits in literature, communication, and culture, get good at a bunch of things. As I'll show you some data later, this program, which just started 3 years ago, is tremendously popular. In some ways, it has saved computing at Georgia Tech in terms of enrollments. At the HCI level, we started 12 years ago, or 11 years ago. Al Bauder started our master's in HCI, which is a bit unique in that you come into this program in 3 different ways. You come in either with an undergraduate in computer science, an undergraduate degree in psychology, an undergraduate degree in media studies, or some related fields, and are admitted into the appropriate department, but then take core courses together, do projects together, but at the same time take some additional specialized courses in whatever your area of admission was, be it computer science or psych or LCC. This too has been a tremendously successful program, very similar to some of the programs that my colleagues at other schools have. Our newest degree program is the PhD in Human-Centered Computing. 3 courses, 3 core courses. I'll describe them very briefly a bit more. 3 elective courses in a variety of areas: social computing, visualization, learning science and technology, software. 3 minor courses. Oh, those elective courses, if you were an undergraduate in computer science, those elective courses could be computer science courses. 3 minor courses and qualifying exam. A very successful, very popular program. A number of our PhD students in this program and in our other PhD and master's programs are out there in yellow shirts this morning. Hello, everyone. The Intro to HCC course, most recently taught by Becky Grinter, focuses on both theoretical and applied aspects at the individual level, the group level, the societal level. And you can see by looking at the readings, the kinds of readings that are used, how broad this course is and how non-computer science-y the course is. HCC2, typically taught by Keith Edwards. Students write typically a 2,500 lines of Jython, doing an instant messaging client is the current project. Students come into this course. Some students taking this course have never had a programming course. Keith works them really hard, and some of those students are in A's. Some of the students take our CS1 course to get ready, a course taught by Mark Guzdial called Computational Media, and then go into this course. Now, it is doable to ramp up quickly and develop the amount of computing savvy and prototyping capabilities that we think are needed for students in this program. And they do some paper reading and give presentations about the papers, about computer science technical papers, to become comfortable talking about those. Third course, HCC3, which is most recently taught by Beth Minett, is really an integrative course to help the students pull ideas together. They work a lot on their research proposals during this time and have a lot of deep discussions. I know one of my students has been in it and has found it very, very valuable. It's a great course. So that's our take at Georgia Tech on HCC education. The question is, what's your take on HCC education? the way for you to input your take on what HCC, HCI graduate, and as well as undergraduate education should look like is to join Paula Kotsky, who's sitting down here, I think. Right, there's Paula. Paula will be having a meeting tomorrow afternoon in room A8 to gather together folks who are interested in taking a fresh look at curricula for HCC and for HCI. The last time we as a community did that was quite a few years ago when Stu led an effort, 91, 92, 93, in that time frame. So things have changed so much, it's really important for us to come together and think about what we should be teaching. Different subject. HCC and HCI, for me, form an important element of the new image of computing. You know, we all know, at CHI, we know that computing and computer science has an image problem. That's not a surprise. How many of us in the audience are coming from a computer science or other technical background? Well, even more than I thought. That looks like roughly half, or close to half. So you all know what I'm talking about. Computer science departments have a great opportunity, if they're prepared to take advantage of it, to use HCC, HCI, media as a way to reform, modify the way they teach, maintaining emphasis on core ideas, but at the same time making it more relevant to people and therefore attracting more people into computing. So, as I wrote a column once in the CRA News, computing, we have a problem. A year or 2 years ago, I started with Rick Rashid at Microsoft, the Image of Computing Task Force, which now has funding from several companies and from all the major professional societies to bring together the many efforts that have been going on to help improve the image of computing, to get more students coming into computing, and to help the world at large understand more about what it is that folks in computing do, that we're not just sitting at a desk 25 hours a day coding, that we're not just wearing the pocket pen protectors, that we're not the stereotypical geeks. I don't see any geeks out there. Where are these stereotypical geeks? So we've got this task force together. The web page is still being, web pages or resources are just being evolved. We're planning a big rollout with articles in all the major professional society publications in the fall. Why are we doing this? Well, many of you have seen this data. BSCS graduates are down. The peak year, so I know it's hard to read maybe hard to read the label. The peak year was 2003, 2004. And that was, even then, enrollments had started going down, but these were the kids who had signed up during the dot-com crash and who hadn't gone off to get rich and who decided that, yes, there's something in computing that I want to stick with. An even worse set of data, this comes from a survey that UCLA takes every year of incoming freshmen and what is their interest in different discipline areas. The vertical axis goes up to 7%. The one peak is just during the dot-com crash. The earlier peak was in the early 80s. You can see that the percentage of men interested in computing has gone down from 6.5% to about 3% during the latest survey that was reported, which is 2004. I have a suspicion it's gone down a little bit more since then. Women's interest is much lower than it was during the 80s. At GW, some of my best PhD students were women. A couple of them are in the audience. At Georgia Tech, the Computational Media program that I described, which is the showing enrollment in the lower green bar, green for increasing, CS enrollment going down, that's the red for decreasing. Put red and green together to the black, and you'll see that our undergraduate enrollments in computing, not in computer science, but our undergraduate enrollments in computing are now leveling off, and looks like they will be going up real soon. The other important aspect of taking a new look at the way we teach computing is that we're getting much more women into both the BS in Computational Media, the MS in HCI, the PhD in HCC, then into the traditional computer science programs. Big, big difference. As well as dramatically increased minority enrollment in these three bachelor's, master's, and PhD programs. Very encouraging, very encouraging. Now, I'm not suggesting that HCC is the entire answer or solution to the decreasing enrollments that we've seen in computing or to the image problems that computing has, but it sure is part of the answer. Certainly another part of the answer is doing things about our CS1 course, whatever our introductory computer science course is. We need to use CS1 not to filter out students, which is what we did when the enrollments were way up here. We couldn't handle them all. We do need to use CS1 as a way to draw students in by making the course interesting. So we need to do things like the courses that Mark Guzdial has developed at Georgia Tech in Computational Media, the courses that Randy Pausch at CMU has developed using Alice, and other approaches that make computing more meaningful. Let's stop teaching students how to sort lists and do insertions into binary trees in abstract, and let's put it into a context of creating images or creating sounds or creating animations. It makes a huge difference in retention and in attraction of students, and showing students that there's more to computing than sorting and searching. So teaching of HCC is becoming more and more of a challenge. You know, I go back to the 70s when I was teaching a course, and Ben was teaching a course, and Don Norman was teaching a course, and there were a handful of people, and there was one course, maybe there were two courses, and that's what we thought was HCI. Now, HCC, HCI is so broad, it encompasses huge, huge sets of topics. How can we as a community come together to help new faculty, the faculty at schools where there is not a broad collection of faculty to teach lots of different subjects? How can we teach new students coming from one discipline to learn some of the key things from other disciplines? I think we can do this with some shared resources and with some shared teaching methods by helping one another, by letting one another have access to our resources and to the ways we go about teaching. So let me do some of that. At Tech, we've developed the Human-Centered Computing Education Digital Library. I'm going to do actually do a live demo if I can get my cursor to move correctly here. Oh, there we go. Okay. Zip off to the digital library. While this is coming up, I'd like to thank the many, many people who have already contributed material to the HCC EDL. In fact, I'm going to ask everyone who has some material in here to put their hands up. Hands up. I know Ben has some things in. Ben, put your hand up. Joe, lots of folks have things in. Thank you, everyone. So, because of the resolution of on the screen, are we going to put the video up there? There it is. Thank you. So there's a pull-out that lets you go into different parts of the library. I might go to, let's see, let's go into careers in HCI. And as soon as our wireless does its thing, we'll get some things coming up. Pop-ups help you understand what's there. We can do a search. If I search on SYLLAPUS, we'll get all of the courses that are in here. So here's Marty's first course on InfoViz, my course on UI design, James Landay's course. Here's Keith's course, the HCC2 course. Here's a CSCW course that I taught in France last year. Here are Wendy's videos that are very useful as a teaching resource. Dave Curis and Bonnie's short course on cognitive modeling. Becky's course on qualitative methods. which has been a very, very popular course at Tech. John's course on InfoViz, course on usable privacy and security, and so forth. The other thing that you see here is and I'll show you a little more of this later, Ed Clarkson's developing a way of helping understand the information space, a result map, and each of these colored items represents a hit in that search. And I can, as I brush over these, for those that are visible, they will highlight as that one. Okay, back to PowerPoint. So I would encourage all of you to both visit the HCC EDL and to contribute to it. The very last link down in the bottom says share, contribute your class materials. There's a form to fill out. Please join with me and many others in making your course outlines, your PowerPoints, your exams, your assignments, your homeworks available to others. I've had many, many notes of thanks to me from folks who are just starting out teaching HCI, teaching HCC, who found this material very valuable. So as I said, thanks to everyone who has contributed, thanks to everyone of you who will contribute, and thanks to the folks who have worked with us to develop this. So we're going to use a search for. This is a short video that will give you a little more idea of what Ed's been up to with his result maps. Where's Ed? Result map is showing with these highlighted. There's Ed. Rectangles in an overall tree map-like environment. This has showing which documents fit where in the overall taxonomy. And you'll see here the labels at the top level of the information hierarchy. You'll also notice here a color coding key that tells us, for instance, that this document is a syllabus, which is yellow, and that these documents here are lectures. We also see one of the advantages of result maps in that we get a sense of where in the overall information space our different documents fall. Other thing that I've been doing with Jason Day, where's Jason? There he is doing an experiment with taking lectures out of the classroom and putting them onto the web. Yes, it's fun to do lecturing in the classroom, but on the other hand, doing lectures in the classroom, the more lecturing you do, the less interaction you can do with students, the less time you have for students to do constructivist things of trying out HCI ideas, of critiquing, of working together on organizing task requirements and so forth. So the idea is, but on the other hand, there's a certain set of ideas that students need to be able to get their arms around. So how to balance these? Decided to try out, not a new idea, but wanted to study it in a controlled way and to see how it works in our context. So working with Richard Catronbone at Georgia Tech in the psychology department, and also with some inputs from Charles Vandermast when I was in Delft, and with a number of faculty now who are recording lectures to use in this way. In addition to myself, John Stasko, Melody Moore has used some of the lectures, and Charles has used them. We also have a Gregory Abad lecture. We record lectures in advance in a small studio, a very low-cost studio. So this is not capturing the classroom. Captured classroom lectures drag on. It's often the case that to watch an entire, let's say, 50-minute classroom lecture in a sitting, if you miss class or whatever, or just doing classroom watching, 50 minutes is too long. It turns out from kind of ad hoc studies, 20 minutes tends to be a good attention span for folks to watch video snippets, video recordings about a targeted subject. So a lot of these web lectures are in the 20-minute space. Some are 12, 15 minutes, a couple dragged on a little bit too long. The lectures are recorded using Microsoft Producer, which then in playback time shows the talking head video with video controls underneath, but it's not just the start and stop, it's also advance a slide, go back a slide. We have a table of contents down in the lower left, which is the titles of each of the PowerPoints, as well as buttons that Jason added that can be clicked on to post to a bulletin board or to send questions to the TA or to the instructor. So this is just a screenshot of that.
I'm going to talk with you today about the use of visual structure in the design of graphical user interfaces. In this presentation, I want to accomplish three things. Firstly, I'm going to describe four principles.
Hence the slightly fuzzy resolution when it's blown up. On iPod, you cannot navigate except with the iPod controls. That is to say, you cannot use the table of contents. It's just there for illustration purposes. Not very many students use the iPod downloadable version of these, and it's actually not something that I've been presenting. This is in fact the web lecture that we used in an experiment that another experiment that I'll describe in a moment, in which I'm talking about 4 principles of Gestalt psychology and how they apply to design of dialog boxes and web pages and so forth. Going back though to the major topic for the moment, which is this idea of using web lectures with students watching the lectures before they come to class, and then in class we talk about the content. We have students doing short assignments about the topic. We use those as discussion drivers, and we do other in-class projects. We ran a quasi-experiment in which I taught 2 sections of introductory HCI to undergraduates. One, the old-fashioned way, using in-class lectures. The other, the newfangled way in which students watch the lectures in advance. We had fewer class meetings of the experimental section to control time on task. We did blind grading, just coded names or coded codes on the homeworks and tests and so forth. Results, students in the web lecture section had grades about 10% better, and subjectively they liked it. They loved being able to watch these at their own pace. The non-native English-speaking students were particularly grateful for having this available because they could stop and replay, listen several times if there were wording issues that were a problem. And we had, again, the subjective preference as well. We're redoing that experiment right now, and we'll have some updated data available very shortly. As part of that, we also wanted to have some understanding what is the value of the different modes that were being used in these lectures. So Jason did another experiment, and we'll be running some more subjects to flesh out some of the results, but we have some very good, some interesting and not unexpected results as well. So we did these web lectures with 4 conditions, and the subject was that 12 or 13 minute web lecture on Gestalt psychology principles applied to graphic design. Condition 1, using the entire web lecture, so the talking head, the audio, the table of contents, the PowerPoint. Second condition, we got rid of the video. We thought, well, in CSCW, the common wisdom is once you know people, you don't need the video, you just need the audio and the shared working space. Let's see what happens when the video comes out. Then also for fun, and also to test how some of the cognitive theories of multimedia might apply, we did also a text-only condition with a transcript of the audio and the PowerPoint. You know, theoretically, because now we're using 2 different textual visual input channels with no audio, no talking heads, we should be overloading certain channels and not making use of other channels. And then PowerPoint only, simply because lots of students will typically just download PowerPoint and look at them and see what the results are. So here are the experimental results. On a 2-part test that the students took after, or the subjects took after watching the web lecture, there was both a retention test and a transfer test. So here are the scores. The full web lecture with the audio, the video, the PowerPoint, scores of 88%, going on down to 69%. Statistical significance between the full web lecture on the one hand and the text and the PowerPoint. Also statistical significance between the PowerPoint and the audio. No statistical significance between the middle 2, as you would suspect. So what does this say to us? Well, it firstly says that the video is important. Why is the video important? We have some hypotheses. One is based on my own experience. If I'm doing an audio conference call and have some PowerPoint about that conference call in front of me on my computer, it sure is easy to look out the window or look at something on my desk or get distracted. If I've got the video there, it's harder to get distracted. It helps keep the attention. It also says we need to have the video, and the good news is that with higher bandwidth, it's now very easy to do video, whereas a lot of folks who did earlier experiments with these had to worry about, had to do CD distribution or DVD distribution. It now becomes easy to get the video to people over all of the broadband access that we have. So some nice results. Tomorrow afternoon, Charles Vandermost, who's co-chair of the SIGCHI education community for the conference, is having a SIG on educational software, software approaches for helping teach HCI. There'll be some discussion of the EDL and the web lectures, but others as well. And Charles, who's sitting right here, invites you all to his session tomorrow morning at 11:30. So what I've suggested to you are, firstly, 2 ways that you can help and that you can get involved in the educational processes within CHI, within HCI, within HCC. One is by going to Paula's activity tomorrow to help with curricular development ideas. Another thing that you can do is contribute material to the digital library. The third thing you can do is go to Charles's session and see if there are some tools that you have or some ways that you've been using software in teaching HCI that you might share with a larger community. So pitch in and help as we look to make HCC education even more pervasive around the educational community than it now is. Thank you very much. And now Stu Card is going to pepper me with a lot of questions. This is a scary prospect.
Yes, Jim's talk provoked a lot of interest from many of you, and so I have a bushel basket full of questions here. Let me start with the first one. I really like the multidisciplinary nature of your HCC program. Why not add marketing, economics, business classes to help people develop something to transfer their HCC knowledge research into a more marketable product?
That's a great suggestion. One of the, certainly, if it's not something that we've been pushing at the moment, but that minor track is a great way for students to take some business and marketing courses, and we would certainly welcome it.
Okay, another one. The decline in enrollment seems possibly an American perspective. What data exists on enrollment worldwide, that is institutions in China, India, and elsewhere? And there's a somewhat related question. Why is the drop in enrollment necessarily bad? During the boom, it was a fad to enroll. Shouldn't we be looking for good people, not necessarily more people?
That's a great question. Firstly, I've been in Singapore a couple of times over the last few years. Their CS enrollments are down. Rick Rashid, who goes back and forth to the Microsoft labs in China and other places. In China, enrollments are down. In Hong Kong, enrollments are down. In Europe, enrollments are down. Why is it a bad thing? It's a bad thing because there are jobs. There are unfilled jobs. If you look at the, now this is data for the US, the Bureau of Labor Statistics has some great data and projections with increasing job opportunities. Computing is, if I recall correctly, the second most rapidly growing job category projected to increase over the next 10 years. There are more folks working in IT now than there were at the peak of the dot-com crash. The myth of job losses to offshoring, the myth of no jobs in computing is part of what the Image of Computing Task Force wants to debunk. And certainly, it is not just an idea of getting more students, it is the idea of getting more good students. Lots of good students, good students have many choices, and we want to make sure that good students understand that there are great career opportunities in computing. But there is a demand, there is a need.
All right, next question. Why is the Hitchhiker's Guide to the Galaxy in the syllabus for HCC 1?
I'll defer that to, let's see, Becky's not here. But Beth can tell us. Actually, we'll defer that question. Beth's going to come up here and tell us, but we'll go on to the next question.
How do you combat?
Do the next question.
Yeah. How do you combat the prejudice hardcore engineers and computer scientists may have towards graduates of the more fuzzy or human-oriented HCI courses?
The way we combat that prejudice is that in a lot of our courses, particularly undergraduate HCI course, we do have a lot of hardcore computing folks take the courses, and they work on teams and doing design projects, and they actually come to appreciate the value of folks thinking in the ways that HCI folks think, so that appreciation does develop. Let's hear about the Hitchhiker's Guide to the Galaxy.
All right.
From the woman in the yellow shirt.
All right, this is a warning to students. Always be careful. You never know what your advisor is going to bring you into. Each year in the HCC1 class, it's very important for us to understand socio-technical systems, and we do that from looking backwards in terms of sociology, studies of technology, such as the Scott approach. We try to understand what's happening now, and we try to understand visions of the future. And science fiction is a great way for us to look at how people have conjectured where advances in computing technologies are going to change the societies in which we live. So we have read Snow Crash, Ender's Game, Hitchhiker's Guide to the Galaxy. Next year's students will get to pick a new piece of science fiction to read. But that's part of just understanding the encompassing vision of how society has changed dramatically by these technologies.
Okay. Now we have questions related to one of the ones we just did. Why do you think is the real reason for the decline in interest in traditional CS? For example, is it a sociological media issue rather than a technical issue? And why is HCC helping to save CS?
So I think there are several answers. Let me answer the second part first. HCC and HCI is part of computer science. It's part of other disciplines as well. But it is important not to think about HCI as something outside of computer science, as opposed to think of it as part of computer science. When we develop an API, we should be thinking about how to design that so that it is maximally useful. When we design a query language, as folks have done, how usable is this query language? When we design an API, what will be the implications on the usability of the applications that are built on top of it? Yesterday in the session on spirituality in the home, which was a slightly misnamed session, Erica Sheehan gave a great presentation on home networking and the challenges in home networking, some of which are brought about by the design of the TCP/IP protocols, challenges that make it hard for mere mortals to get their home networks going. And then the other question was why the decrease in interest in CS. About 5 years ago, we had what I call a perfect storm in a negative sense. It was the outsourcing hullabaloo. It was the dot-com crash. Came together along with a lot of old-fashioned stereotypes that have been promulgated in media and in the press about what computer programmers do. And so it's that geeky image, which is just not the right image. There's the image of solitary work late at night. There's the image of folks going off and writing games that are violent and brutal, forgetting about all the good kinds of games that are out there, the social, the motivational games, the simulations of SimCities, and so forth. So again, this is part of what the Image of Computing Task Force wants to do, is help project and help not create an artificial reality, but to help the world understand the reality of computing.
Have the sources of funding changed since have the sources of funding for advanced research changed since you started the GVU? Since you started, GVU had a lot of government DoD money originally. Has that changed? What are your thoughts about funding and its effect on academic research?
What was the last one? Which one? About funding. Oh, and it's, oh. So GVU had very little DoD funding, that is to say DARPA funding. I had a nice DARPA project with Bob Netschys at ISI, and Pedro and Noe worked on that, and Surgeon and others. But most of the funding was NSF and government. Sorry, NSF and industry. And GVU Center with best leadership continues to have a lot of good industry funding. I think some DARPA funding. There has been a real crisis in funding within NSF and NIH, and one of the things that the Computing Research Association has been doing on the behalf of all of you is working very aggressively along with a lot of other organizations. The good news is that NSF funding is now on a track to increase back up after some years of stagnation and with inflation even going down a little bit. So we have, on the other hand, the trough is getting bigger, and there are many more computer science, computing, HCI, and so forth, professors out there writing proposals, and it's not clear to me that the per capita amount of funding that's available has gone up.
With the web lectures, how did you integrate textbook and other sources?
The way we use the textbook and other sources, we have assigned readings that go with the web lectures. And I do have the impression that a lot of students only use the PowerPoint and the web lectures for their sources. Some of the students use the preset all book that I use in my course. And the content of the books reinforces the web lectures. I typically, myself, have not been talking a lot about specific things in the textbooks.
Okay, I think we have time for about one more. Many philosophical fields, phenomenology, epistemology, Wittgensteinian linguistics, humanities, are relevant to HCI. What is the best way to introduce these into the curriculum?
Well, that's good. I think personally it's not possible for any one curriculum at any one institution to encompass all of the disciplines that I listed, and including ones that I didn't list. I think what we're going to have is an evolution where different schools have different emphases, some taking a more of a broad sociological approach, perhaps some taking a more philosophical approach. I think the important thing, and what we're trying to accomplish with the HCC 1 and HCC 3 courses, is to get students able to appreciate that literature and understand how to integrate it into their own particular piece of research, even if we haven't been explicitly teaching about it in any of those courses.
Okay, well, thank you very much.
Okay.
I think we're set.
Thank you.